Hello everyone, I am Mrs. Meenal Nerkar, working as Assistant Professor in Computer Engineering Department of All India Sri Shivaji Memorial Society's Institute of Information Technology. Today we will see how to reverse a linked list. So linked list can be reversed in two ways, iteratively and recursively. Today we will see how to reverse a linked list recursively. Whenever we are making use of the recursion, internally it makes use of the system stack for storing the return addresses. Now consider the real example. The list is containing the element 1, 2 and 3. So 2 is the successor of 1 and 3 is the successor of 2. Now when control comes over here in the recursive function, or this is the reverse function which is taking the base address of the list to be reversed. So over here the base address is this head which is pointing to the node 1. And it returns a base address of the reverse linked list. We will first check whether the head is null or not. This condition is checked if we pass the empty list for reversal. So in that particular case it will return the head and control will come out of this function call. Or the second condition is if the list is not empty, it contains some nodes. So in that particular case we are checking for this condition, head arrow next, whether it is equal to null or not. Okay. If it is null, we are returning the head. At this particular point, head arrow next is not equal to null, it is containing the address of 2. So it in turn will give call to the reverse 2. So from reverse 1 we have given call to the reverse 2. So head arrow next, that is head arrow next is address of 2. Okay. Again control will go over here. Now 2 will become the head. 2 will become the new head. It will check the condition whether head arrow next is null or not. Head arrow next is not equal to null, it is containing the address of 3. So control will come over here. It will recursively give call to the reverse linked list. Reverse linked list, and we are passing the parameter head arrow next. So from reverse 2 we are giving call to the reverse 3 because head arrow next is 3. Okay. After this control will come over here. Now our new head will be the address of 3. Okay. Now over here if you see head arrow next, now head arrow next 3 arrow next is null. So this condition is satisfied. So it return the head. So address of the head is written and that address is getting stored where in the this we are returning from the reverse 3 function call. Okay. This is returned to the reverse 2. Okay. And what we are returning? We are returning head arrow next. So this is my head. Okay. 2 is head and head arrow next is 3. So where that address of 3 is getting stored? So the address of 3 is getting stored in the rest. So if we see this 3, it will be getting stored in the pointer rest. After this, what we are doing? Head arrow next is equals to head. currently head is pointing where? 2. So 2 arrow next is 3. Okay, arrow next is equal to head. This means what? 3 starts pointing to 2. Okay. Then what we are doing is head arrow next is equals to null. So head is 2, 2 arrow next is equal to null. So this link is broken. These two steps in the function are doing the actual reverse. After this, the control will come from where? It will come out of the function call head2. It will return the control back to the reverse 1. Okay, now 1 will become the head. Okay. So now it will again execute this statement. Head, which is nothing but 1, arrow next is equals to head. So 2 will contain the address of 1, and now we are doing head arrow next as null. So this link will get break. Okay. So now we have completed with all the functions call to the reverse. At the end it will return the base address of this reverse function, which is nothing but the base address of the reverse list, that is nothing but this rest. Okay, so after completing this particular function call, what we will get is 3, 2, 1, and next of 1 is null. Okay, so which is nothing but the exact reverse of our original list, which was 1, 2, 3. So the time complexity of reverse operation is big O of n, where n is the total number of nodes in the list, because for reversal we have to traverse the entire list. But the in case of recursive version, as it makes use of the internal stack for storing the return addresses and the local variables, that is the parameters passed to the function, it is using the stack. So the space complexity of the recursive version is greater than that of the space complexity of the iterative version. Hope you understood this particular recursive version of the reverse linked list. Thank you.